Hello there, welcome to Pluralsight. My name is Tim Werner, and this module is entitled Networking Tools. Here at Pluralsight, we build learning paths to help you conquer IT certification exams. The learning path for our CompTIA A+ 22901 certification exam consists of a handful of courses. Each course in turn is composed of a series of related modules. The introduction is just what the word says. It serves to describe the certification and related topics. Hardware, again, pretty self-explanatory. If you've been moving through this learning path sequentially, you're yawning, please feel free to skip ahead. We're finishing the networking course right now. This is the final module in that course. Then we have a separate course on mobile devices, and then finally troubleshooting. I've divided the content for the networking portion of the CompTIA A+ 22901 into 8 modules, and as I said, this is the last one. So if you've been through them all, congratulations, because you've built up a really nice skill set. Network cables and connectors, and TCP-IP basics, ports and protocols, Wi-Fi networking, small office, home office networking, internet connection types, network architecture devices, and here we are, drumroll please, networking tools. What are your learning goals for this module? Pretty simple, just 2 bullet points. Hardware tools and software tools. This is all about expanding your tools as an A+ certified PC repair technician. Now, elsewhere in the learning path, I teach you the tools that you should put for PC repair into your tool bag. Here we're concerned with network visualization tools. Some really good practical advice here, as well as giving you what you need to know to pass related questions on the exam. Meanwhile, in the real world, what are you likely to be asked as a repair technician? That deals with networking, because let's face it, you may be very well working not only as a PC bench repair technician, but also as a network technician. It's very easy, too easy sometimes, for us IT pros to wear several hats where we work, simply based on supply and demand. The demand is the fact that everybody has networking issues, everybody has some sort of electronics or hardware issue, and supply means that there are generally far fewer of us qualified IT pros than there are people to help. Thus, how do you answer the question, I have a new employee and she can't connect to the network? Obviously, that's a broad concern. We're going to address this throughout this module and revisit it at the end as usual. Another is a more technical question. You may be asked by a business leader in your organization, somebody who's maybe not an in-the-trenches IT pro like you are, but knows a little bit, who says, look, I was suggested that we expand our wireless because we're not getting good enough coverage in certain parts of the office. Is the cost for another access point justified? You'll find that those who are in decision-making capacities at your work will be concerned with budgets and dollars and cents. And if you're asked a question like this, you want to be diplomatic, but you also want to make sure to be as accurate as possible. Let's get going. Our CompTIA A+ 22901 objective here is 2.9, which says, given a scenario, use appropriate networking tools. Hardware tools. When I looked at the relevant objectives here from the CompTIA.org A+ blueprint, I saw that the tools that CompTIA wants us to know fall into 2 categories, so that's why I'm separating the content along hardware and software lines. Hardware, of course, refers to physical items that we can touch with our fingers. Cable crimpers comes to mind. If you are tasked with terminating your own Ethernet cable, this is going to mean that you need to know about IATIA 568A or B. It's also going to require that you have certain physical tools to attach the RJ45 ice cube connector to the end of the naked cable as you see it left. Cable crimpers are what you use for this. Most cable crimpers that I've used have 2 holes in them, one for the RJ45 form factor and the other for RJ11. Now, it's a big cost savings for a company to create your own Ethernet cables as opposed to paying a premium for pre-made cables. You can actually purchase a spool of category 5E, 6A, whatever cable, and a whole big bag of RJ45 plugs. And then by using your tools, you can terminate those cables yourself. That, again, is going to be a cost savings, and it also is helpful because you can create cables of the exact length that you need. Of course, this introduces the question of human error and how to account for it. We'll discuss that later. Wire strippers, another tool that's important for terminating cable. What you do with these is crunch down the handle like you're using a pair of scissors or wire snippers, and you want to be careful not to cut down past the outer jacket. You'll notice that this wire stripper has different size grooves depending upon the grade of cable. Our goal is to strip off the outer insulation or the outer jacket to expose the cables inside. Notice that there is a blade there where you can actually make a clean break if you need to. You'll see that unshielded twisted pair cable, or UTP, often includes what's called a spline. It essentially looks like a string, a very thin string. And what you can do is pull the spline down to split the jacket, and then you could use the wire strippers very carefully. It's to help you expose the conductors of a cable, but not nicking the conductor itself. That's obviously going to defeat the whole purpose of termination, isn't it? Snips, just as self-explanatory as can be, you're going to make a hard cut here. With enough experience, I've seen people, I don't tend to do it, but you can use snips to strip the jacket off of cables, but notice that there's no groove that serves as a guide or protector. So again, you want to be really careful that you don't nick a conductor in the process. A digital multimeter is a workhorse tool. We saw this earlier in the learning path, specifically the module that I did on power supplies. We can use multimeters to measure any electrical property, at least the three main ones: voltage, current, and resistance. So what do we use the multimeter for in terms of those quantities? Well, we can verify power supply voltages. If you want to test a computer power supply to make sure that it doesn't have some sort of problem, you can verify those voltages. Remember, those are generally 3.3 volts, 5 volts, or 12 volts. Now, if you look at right at the digital multimeter, you'll see that there's a black ground lead and a red hot lead, and the dial allows you to switch to what you're testing, whether it's voltage, current, or resistance. You'll note it's difficult to see in this image. You'll want to say go to Google Images or go to the store and actually hold one in your hands. The voltage comes in two flavors. There's going to be your alternating current voltage and your direct current voltage. And you just set the dial to the type of quantity you're measuring as well as its expected output. So you'll notice, for instance, on the DC voltage, there's 220 and 200. If you're going to measure 3.3, 5, or 12, you'll probably set it to 20. You could go to 200, but by setting the cap on the meter to 2, that's not going to get you very far. You can also measure wall voltage using the AC side. Tone generator and probe. This is really useful. Boy, I'll tell you what, from a network technician standpoint, you're going to probably get more use out of a tool like this than anything else if you're visiting multiple client sites. If you have clients who say, we have certain users who claim that they're getting inconsistent network access, you'll want to make sure that you have continuity of the cable from their wall drop to the patch panel and to the patch panel to the switch. And you also run into cases where they don't know, due to lack of documentation, where cables are terminated. So to figure out where a particular outlet maps to a particular port in the patch panel in the wiring closet is referred to as cable tracing. So we do this for troubleshooting purposes, documentation purposes. If you look at right, the cable tracer has two sections. You have your remote, which is what you plug into, say, the outlet. You're going to need two people to do this unless you really want to do a sneaker net thing and walk it yourself. But one person will plug in the remote into the user's wall port, and then you'll walk down to the telco closet or the wiring closet and use that wand to wipe it across all of the patch panel ports. When you get continuity, the cable tracer makes a really loud, obnoxious noise and will light up its signal light. So it's a way to quickly figure out, aha, that user who's out at wall drop 14 corresponds to the patch panel here on port 3. You see what I'm saying? You can also use these network tools to verify continuity, but stuff like continuity, you're better off using a dedicated cable tester. What is continuity, you're probably asking? Hang on, we'll cover that shortly. A cable tester or cable tester kit. Oftentimes these kits will include the toner and probe in the kit itself, are absolutely required if networking is going to be any significant part of your job role. A cable tester is going to allow you to test, well, very simply, whether a cable is working properly. For instance, again, you might have a user who's experiencing intermittent problems on their connection. If you switch their computer to another wall drop and you find that the connection is fine, you might think, okay, well, there's probably some kind of termination issue or wiring issue going on here at this user's connection to the patch panel. So depending upon how much money you want to spend for a cable tester, you can verify continuity, which means that the signals that are going from the user's side match up to the wires and the termination on the patch panel and the switch, that you don't have a short or an open or a miswire. You can also verify speed to verify that the cable is carrying the data that you're expecting it to carry in terms of speed and so forth. Depending again upon how much you want to spend, Fluke Networks is like the Cadillac or the Lamborghini of network testing tools, and you're going to pay a premium for that, of course. Will actually allow you insight into the cable in terms of, okay, I see that you have an open on the cable. There's a wiring problem physically on wire 5, and it occurs 3.6 feet into the cable run, you see? So you can actually visualize to a great degree of accuracy and depth what's happening. What we're doing here essentially with these cable tools is that we're allowing ourselves to visualize stuff that ordinarily would be impossible to detect with the naked eye. I mean, if a computer is having a problem physically on the motherboard, a lot of times you can tell just by looking, for instance, an LED light indication. But anything that gets into abstracts like zeros and ones and electrical pulses, we're going to need to rely upon a hardware or software tool to give us that insight. In terms of some of those problems with continuity and shorts and so forth, well, a short may be more of an electrical problem, but depending upon how accurately the cable was terminated into either the wall outlet or the patch panel, you might have, again, different types of problems show up. The tool that we use to terminate the Ethernet cable, the copper cable anyway, is what's called a punch down or impact tool. You see on the end, it looks like a combination of a screwdriver and a blade, and that's true. The punch down tool does two things. It pushes the 8 wires in your unshielded twisted pair cable into copper terminals in either a wall outlet or on your patch panel, and they've been separated out, those 8 wires, into the IATIA 568A or B orientation, and the blade is responsible for snipping off the excess. I have a picture that illustrates that actually. Yeah, here it is right here. This is the reverse side of a wall plate. When I talk about a wall plate or an outlet or a drop, I'm referring to something like this, a finished termination that you'll use to cable a user directly into your network, or at home you might install these to make it easier, for instance, to put your game console or your television onto your wired LAN backbone. But you'll see that you need some sort of tool to punch those conductors down into the associated terminals and the blade that snips off the excess, so you wind up with a really nice, lean and mean connection. There's a lot of human error that can take place here, though. Someone like me, I'm worthless doing this due to my color blindness. I have a fair amount of dexterity, but that's another problem. If the technician's not particularly dexterous, you can accidentally punch down 2 wires down into the same terminal and create a miswire. You might have a wire that's not fully punched down, that's going to create an open, or you might have nicked a conductor that creates a short. You see, so there's a lot of human error, unfortunately, that can happen here. Here's a picture of the 110 block, which is the reverse side of your patch panel. It looks like a spider web mess. All the cable bundles are coming through the wall, through the ceiling, through the floor, and terminating into your wiring closet and are individually punched down. I've seen experienced network technicians work like lightning punching these things down. It's pretty amazing. I'm very slow at it myself. The loopback plug. Now, what the heck is that? The loopback plug has a couple different reasons for being. It's used to trick or fool an operating system or application into thinking that it has an active network connection. Way back when, and I'm talking in the late 90s, the Windows NT business operating system wouldn't install unless it actually had a live internet connection. And if you weren't ready, for instance, to put a new server that you were building on your company LAN, you could shut the operating system up, so to speak, by plugging plugging in an RJ45 loopback. Now, as you see at right, I'm showing you a copper Ethernet and a fiber Ethernet loopback plug, and they literally loop back or terminate immediately. So you're not sending out data past the plug itself. You might think, well, why the heck would you use that? We're way past needing to trick or fool the computer into thinking that it's on the network. You can actually use loopback plugs even today as a really quick sanity check to test network cables or switch ports. If you plug in one of these guys into a switch port and you get a connection LED, then you can at least verify at a low level, at a layer 1 or potentially layer 2 level, that that port or cable is valid. Now let's turn our attention to software tools. These are going to be tools that run on a host computer. Perhaps you have what's called a crash cart, which is simply a mobile wheeled cart on which you have, say, a diagnostic workstation and a monitor. Sometimes I've seen in data centers where all of your servers are headless and racks where you don't have the ability to plug in a local keyboard, mouse, and monitor. Crash carts can come in handy there, and they can also come in handy for doing network analysis. Now, speaking of which, a protocol analyzer like Wireshark is a really good way to visualize network traffic on a frame-by-frame basis. I'm calling out Wireshark. There are many other tools that do protocol analysis, but Wireshark is beautiful, I think, for so many reasons. Number one, it's pretty universal. It runs on major desktop and server OSs like Windows, Apple OS X, and Linux. It's also open source and free. You can't beat the price. We can use it to analyze wired and wireless Ethernet traffic, and because it's free and open source, that means that the Wireshark community can create decoders and parsers to understand just about any kind of network traffic under the sun. In this screenshot, I took this on my Mac computer. The traffic is pretty bread and butter. We're seeing TCP and TLS traffic, DNS lookups, ICMP, but in a troubleshooting scenario, you might have specific types of messages that you need to see to diagnose errors. A tool like Wireshark can be awfully useful in that regard. Now, to tie this into what we learned in the previous module, remember I told you that hubs are often useful when you want to do something like this because you're able to put both your monitoring station as well as the monitored target station on the same collision domain, and therefore you can sweep up all of those frames. That's useful because in a switch, remember, each switch is sort of isolated unto itself. So if you want to use a tool like Wireshark to capture traffic from other switch ports, you're going to need to do techniques like port mirroring, where you can instruct the switch to send traffic from port Y over to port X, where your workstation is hooked up. Alternatively, you can unplug the target from their switch, plug it into a hub, plug your workstation into that same hub, and run the protocol analysis there. Actually, you'll want to uplink the hub back to the switch to make sure that you all can connect to the rest of the network. That's called hubbing out, and I'm kind of geeking out here, giving you too much information. Let's proceed. For Wi-Fi, again, this is an important protocol suite to visualize. There are so many Wi-Fi analyzer tools. I've mentioned Ekahau Heatmapper, but using your phone, your Android or your iPhone, go to your App Store and look for Wi-Fi analyzers. You can build these heat maps that show where you're better connected versus less well connected in your home office or in your business office. You can attach actual floor plans, or in many cases, you can simply draw a floor plan and upload it to the Wi-Fi Analyzer app. And then when you walk around your site, you can simply click to take a measurement and plug it into the appropriate area on your map to create your own heat map. So whether you want to use a solution that can automatically do a heat map or you do it yourself, either way it's useful because it's going to give you metrics to determine, for instance, how well covered are we with Wi-Fi and so forth. This is a tool called Insider that is nice because it can visualize not only your own WLAN, but any other WLANs within range and show you what channels they're operating on, what kind of encryption, security protocols they're using. And this is useful for optimizing your own WLANs to make sure that you have as free and clear a channel as possible. This is just an extra I'm throwing in, Wi-Fi Pineapple. One of my colleagues at Pluralsight, Andy Newman, turned me on to this. In fact, the company that makes this makes some other really interesting network utilities. You should check them out, WiFiPineapple.com. What this is, it's a hacking tool, really, and it could be ethical hacking, white hat, it could be black hat, but what it is, it's a mobile hotspot. You see the two antennas make that pretty clear, that you can use to gain so much more information about your WLAN and those that surround you than you can with just using traditional software. So you'd use this tool in a penetration testing environment. You could run different hacks and attacks on your WLAN. For instance, you could set the Pineapple to try to steal connections away from your business's WLAN and feed them through this device. That would be a black hat move, of course, normally. But if you do this in an ethical hacking context, you can really identify the vulnerabilities in your business WLAN and develop countermeasures against them. In this demonstration, we're going to use a piece of software called the CompTIA Network Plus Hands-On Lab Simulator from Pearson. This is another tool that I helped develop when I worked for Pearson. And the goal here is to give us the ability to play with some cable testing tools, even though, of course, in a computer-based training environment, we're not standing together in the same classroom, so we can't actually touch equipment live. This is probably the next best thing, though. Now let me bring up this page. This page shows an example of a network cable tester. Now notice the display shows two sets of 8, 1 through 8. Remember that there are 8 conductors in copper Ethernet cable, and one set of 8s refers to the local side of the connection. So let's imagine that we're helping a user. We're at his or her cubicle, and we use the remote RJ45 plug. It comes out of this device into their drop in the wall, and that's going to represent the near side 8 conductors, and then there'll be a remote on the other side in the patch panel in the telco room. Actually, some cable testers, you don't even need to plug a remote on the other side. It can do it itself. It depends, again, on the device. While we're on the subject, something else that is really awesome, I think. A company called Patchmate makes a cable tester that actually does continuity testing and tracing all at once. You see these little plugs with RJ45s on the end? You actually plug those into your patch panel. Notice that you can fully populate a switch with those plugs. And what happens there is then you can use the remote, which this guy's holding right here, and then you'd move from wall outlet to wall outlet. Like this would be best done with 2 people, of course, one using the remote and the other person inspecting the plugs in the patch panel. But the ends of those plugs will light up when a match is made, so that allows you to trace the cable. But the plugs have built-in continuity testers. Those are 8 little LEDs that you see on each plug, and so it'll actually confirm that you have full continuity. If there's a short or a miswire detected, it'll tell you. Isn't that awesome? So anyway, just know that, the fact that you've got so much flexibility in terms of cable testing nowadays. The objective of this exercise, I'm just going to read it here, is to identify common problems with Category 5 cables. Examine the output shown in the wire maps and drag and drop the correct terms to the cable tester. Okay, so the 3 possibilities are an open, which means that you have an open in the circuit and the zeros and ones are just disappearing. You have a short, which is going to ground out the connection and prevent data from going, and miswire, which is the same thing. If you don't have the wires lined up 1 to 1 on either side of the cable termination, then again, you're not going to get data through there. So look at the output. You see in block 1, let's see, we've got 1, 2, 3, 4, 5, 6, 7, 8 on the remote side, but 1, 2, 2, 4, 5, 6, 7, 8 on the near side. What does that tell you? Well, what this tells you, look at the 3-lane. The remote side reports it should be conductor 3. That is indicative of a short. Let's go to the second one. When one of the sides of the equation is blank and there's no signal, that should tell you that some zeros and ones are disappearing from the circuit. That's an open. And finally, number 3, it looks like here we've punched down 1 into 2 and 2 into 1. That is a human error miswire condition. And then we can check our answers. We're correct on that. Final point I'll mention here is that depending upon the category of cable that you're using and the type of Ethernet, say fast Ethernet, which is 100 megabits per second, and gigabit Ethernet, that's 1000 megabits per second, you may not see a problem when you're using fast Ethernet, but if you decide to bump up the speed to gigabit Ethernet, you suddenly see problems. Recall that in fast Ethernet, you're only using 4 of the 8 conductors in an untwisted pair cable. So that means you could have a miswire or a short or an open in one of the not used conductors, but you won't see that because in fast Ethernet you're not using those wires. When you move to gigabit Ethernet, you're actually using all 8 conductors there. So definitely if there's a problem, it will rear its ugly head immediately. Now let's return to the real world as A+ certified repair technicians. We have the problem a new employee can't connect to the network, and also is the cost for another access point justified? With reference to the first question, we'll want to look at the lower layers of the OSI model. We'll want to look at layer 1. Is the user's cable patched correctly from their computer to the wall outlet? Layer 2, you want to look at the user's network interface card and make sure that it's lighting green and not red. You want to do the same thing at the other side of the termination in the switch. Make sure that you have a green LED and not some kind of warning or error state. Moving beyond that, you might want to replace the patch cable that's connecting the user to your wall drop and/or use a cable tester to test the cable run to make sure all is okay. With regard to the access point question, I would just simply say it's a complicated question that normally has a complicated answer. You'll want to develop quantitative data to show to your boss. You might have the hunch based on feedback from your users that you need to spring for another access point, or maybe even an access controller, a wireless LAN controller, but the person or people holding the purse strings are really going to be interested in numbers. That's what quantitative means as opposed to qualitative. And you can do that by performing, for instance, site surveys and do different network tests, generate reports. Pretty pictures are always good because they're easier for non-technical people to understand, and then you'll have a much better chance of having your request approved, if your experience is anything like mine. For further learning, Ross Bagurtis has troubleshooting for CompTIA Network Plus, and in that course, he discusses and shows you how to troubleshoot cables, wired Ethernet, as well as wireless Ethernet. Avril Salter has a course in our library called Implementing Wireless Security in a BYOD Environment. BYOD stands for Bring Your Own Device, and it concerns actually what we're going to do in the entire next course, which is mobile devices like smartphones and tablets and smaller form factor laptops. It's deep content, but you might find it insightful, especially if you're a more advanced student who already has some industry experience. In summary, you now have some really cool networking tools that belong in your PC repair tool roll. Actually, a tool roll is probably not going to cut it. You'll want to actually have a toolbox to hold your network testing. Depending upon how comprehensive your network tester is, your cable tester, it might have its own case for that matter. Now, network troubleshooting is a case where you're face-to-face with the OSI model, so I hope that I've succeeded in transmitting to you how important that model is, and that although initially there's a lot of memorization, the ports, protocols, the protocol data units, and so forth, it eventually becomes a language that you just use organically. When you're dealing with problems, you think layer 2, layer 3, and other technicians also speak that language, so it makes it much more efficient. Now, the caveat there is you want to be careful not to be throwing around OSI layers with non-technical customers. That's going to alienate them and potentially limit your business prospects with them. Well, that's it for this course. You have learned a lot over the course of this course, of course. If we look at the learning path from start to finish, we started with hardware, so that gave you an excellent grounding in the mechanics, the inner mechanics and outer mechanics of a computer system. In this course, we looked at networking and how that applies to PC maintenance. We're just going to keep on rolling in the next course and focus our skills, all of which we can apply to the mobile device arena. It's going to be a lot of fun. Thanks a lot for hanging in there with me. I look forward to teaching you all that material in the next course. Take care.